Alright, okay, again in this video I'm going to show you that how to show that this function is represent a continuous, right? The x here, the x is actually a continuous random variable, and this function is represent a probability density function. Alright, so probability density function for a continuous random variable x. So very simple. So as you must the first condition will be the fx must be a positive, right? The value of y here, or we said y here, for all the x value here that define, if you put inside here the from 1 to 3, the fx is positive, right? It's positive, and from 3 to 6 the fx is positive, all right? Then this is the first condition. The second condition will be the integrate for the negative infinity to infinity, positive infinity for fx must be equals to 1. So actually this can be the meaning is if you integrate for all the interval, right? For this is a given interval. For all the interval means that you integrate, you evaluate the integral from 1 to 3, right? You integrate the interval from 1 to 3 for this function x minus 1 over 5 dx, and total up the integral from negative infinity to infinity. The meaning is you integrate all the interval, right? You total up all the interval, the integral for all the interval from 3 to 6, right? From 3 to 6 that belong to this function, 2 6 minus x over with 15, right? So there are no other interval, because other interval beside this is considered as otherwise, which is 0, right? So if you're able to show that the value of this integral after you total up, after evaluate, you're getting the value of 1, right? You're getting the value of 1. Then this will be the x in this function here is represent the continuous random variable, and automatically this is called the probability density function, because it's represent the probability density. All right. But at first you must show that this is equals to 1, right? So if the question asking you to show that this is a probability density function for a continuous random variable, okay, then you have to integrate for all the interval. So I hope you understand. So now I start integrating here. So this one, if you integrate, okay, you can write as x minus 1 to the power of 2, right? Linear, right? 2 over with 2 times 5, you have 10. So it's from 1 up to 3. All right, from 1 up to 3, and for this you also can integrate 6 minus x to the power of 2, right? Power of 2 divided by 2, right? Divided by 2. Here you have a 15. If you divide it by 2, right? You divide by 2. The 2 and this 2 you will cancel off, right? Cancel off. So then it's from 3 up to 6. Okay, let's evaluate the integral here. So 3 minus 1, right? 3 minus 1, you have 2 to the power of 2, 4 over 10, right? Minus with 1 minus 1, 0, right? For this integral. So 6 minus 6, 6 minus 6 is 0, right? 0 over 15, minus away. 6 minus 3, 6 minus 3 will be 9, right? 6 minus 3 is 3. 3 squared, you are getting 9 over 15, right? You are getting 9 over 15. So, okay, let's look at it. Oh, sorry, there is a mistake in integration here. If you power of 2, right? If you power of 2, okay, I explain again. So if this is power of 2, right? If this is power of 2, you integrate, you're getting power of 2, right? So then you divide by 2, right? You divide by 2, then the 2 and this 2 here, you will definitely cancel off, right? Okay, I just write here, okay? I just write here. You divide by 2, and here you have a 2, then you cancel off. But don't forget, just now I have already forget. So which is you need to divide by the coefficient for x, right? Coefficient for x, which is -1, right? Do you still remember the formula for integration, right? -1. So suppose here you have -15, right? -15. Negative, you're getting positive, right? So you have 4 over 10, 4 over 10, plus with negative, positive, 9 over 15, right? If you simplify this, you will get 2 over 5, right? If you simplify this, you will getting 3 over 5, right? So 3 over 5, so 2 plus 3, 5 over 5. Then you have already showed that 1, right? You have already showed that it's 1. This is the most important thing, okay? You integrate everything, you're getting 1. But if you integrate everything for all the interval, if you get a number which is not 1, either is greater or 0.5 or 0.7, which is not 1, all right, this shows that this is not a probability density function that represent the continuous random variable, all right, the continuous random variable. So at first, the fx have to be positive, and okay, later I show you what is meant by fx have to be positive, all right, have to be at least 0, okay. Now I have shown you that it's already 1, right, or it's already equals to 1, okay. Now I'm going to explain, okay, by sketching the graph, all right, by sketching the graph. All right, now I'm going to sketch the graph. Sketching the graph of a probability density function is also very important to view the, all right. Okay, let's see. So now this is your fx, okay, fx. So usually we just sketch the axis so that it's above, okay, above. So okay, later on we see that there's a random variable from 1 up to 6, right? 1 up to 6. So 1, 2, 3, 4, 5, and 6, right? So okay, and this is a straight line, right? This is a straight line. So straight line, you just need 2 points, right? 2 coordinates. So you're putting 1 to find the value of y here, right? 1 minus 1, 0, right? Oh, sorry. So if you substitute 1 minus 1, you are getting 0, right? 0. So means that this will be 1. During 1, it will be 0, right? During 1, it will be 0. During 3, right? 3 minus 1, you have 2 over 5, right? 2 over 5, 1 over 5, 2 over 5, okay? 2 over 5. So probability during 3, it will be 2 over 5, right? Then you draw a straight line, right? Because this is actually represent a straight line. So later on, I'm going to sketch another straight line here. This is also a straight line function. So, okay, 6 linear function. So if you substitute with 3, right? 3. So, okay, 3, 6 minus 3, right? 6 minus 3, you have 3. 2 times 3, you have 6 over 15. 6 over 15 is actually 2, 3, 6, 5, 3, 15, right? So it's also 2 over 5, okay? It's also 2 over 5, means that during 3, for this is 2 over 5, and 3 for this is also at 2 over 5. So finally, you have this point, 6 minus 6, 0, right? So means that during 6, your fx will be 0. So if you're sketching the graph, you can see that it's actually looking like this way, right? So this is the graph of function for this probability density function. Okay, you can actually, you can see that the function here, the fx is greater than 0, right? Your fx is greater or equal 0, right? At least 0, right? At least 0, and it's above, right? The fx value here will be greater than 0 and above the x-axis. It will not exist below the x-axis, right? It can be around here, it can be around anywhere, right? But it must be above the x-axis. There is no graph below here, right? This is the first properties of probability density function, okay? It must be above the x-axis, the graph. And the integration, right, from negative infinity up to infinity must be equals to 1 to further verify. So, okay, of course, this is to tell you that the area, all the area will be 1, all right? The area will be 1. You can try to calculate the area for this, right? The area of triangle, half, right? Half of the length of the base, the base. This from 1 up to 6 is 6 minus 1. The length here is 5, right? 5, and the height is 2 over 5, right? 2 over 5. So you were getting 1, right? You were getting 1. So the area under the graph for a probability density function is different. it must be 1, right? It must be 1. So, okay, and at the same time, the question is asking us to find the mode, right? Refer to the notes, okay, your lecture notes. So they're asking us to find the mode, right? The mode for this probability density function, all right, for this continuous random variable. So from here, from the graph, right, you have to identify the mode from the graph. Okay, from here, very simple. Which one has the highest density? Highest probability density, 3, right? 3. You see that? 3 has the probability density of 2 over 5, right? 2 over 5. So means that the mode will be x equals to 3, right? Because it has the peak point, the maximum, okay? The highest point. So x equals to 3 will be the mode for this function. Alright? Okay. So the first thing is you must know the knowledge of verify that this is a probability density function for a continuous random variable. Okay, and then now you're able to sketch the graph for this probability density function. You sketch the graph. Then from the graph you can see that the graph must be above, must be at least 0. That's the meaning here. As you study the function, right? You study the function, the value of y, the range of y must be at least 0. It cannot happen. It won't have graph below the x-axis, right? No, right? It can be anywhere around here. It can be here, can be here, can be anywhere, but it will not below here, right? So this is a first property of probability density function, and the area under the graph must be 1. Okay, and from the graph you can identify the mode. All right, jot down. So okay, later on, how to using this graph, how to using this function to find the probability, right? Since we only can use this to find the probability if this is already verified is an probability density function, right? Okay, let's see.